Welcome back to the online learning. In today's class, we will be going to learn about Haemocytometer. Haemocytometer was one of the important methodology that is adopted to assay the cells, to enumerate the yeast cells, or to enumerate WBCs, RBCs, fungal spores. Haemocytometer is one of the direct microscopic count methodology which gives us an idea about the number of cells that are there in the given suspension. Haemocytometer looks like a thick glass slide which has two steel linings like this, which has a particular grooves and partitions in them. When visualized under the microscope, this is the partition that we could see. In today's class, we will be learning more about the calculation about the yeast cell enumeration. To enumerate yeast cell, what is the calculation that we can take up? Here, this is the haemocytometer, which has the two thick steel layers in them over which we keep a drop of the given yeast cell suspension, add cover slip and weave it under the microscope. When we weave it under the microscope, we could see the grooves and corners like this, where this is 3 mm, whereas only the large squares, if you take it, is going to be 1 mm. We can see that the four corners are made up of 4 into 4 cells. These four corners are made up of 4 into 4 cells, and the middle square is made up of 5 into 5 squares. So this is the overview about the haemocytometer partitions or grooves in them, which is used to enumerate yeast cells. When we speak about the area of one large square, it is going to be 1 into 1 mm. That is the length into breadth, that is 1 mm square. When we keep it as an area of one large square, it is going to be 1 mm square. When we take the depth of the square, it is going to be 0.1 mm. When we speak about the volume of the square, that is going to be length into breadth into height. Height would be the depth in this case, which is going to be 1 mm into 1 mm into 0.1 mm, which is the length into the breadth, and this is the depth of the each square. So this comes up to 0.1 mm cube, which when written in centimeter, it is going to be 10 to the power minus 4 centimeter cube. This remains constant because this is how the haemocytometer is its capacity, that is its volume, that is its area, that is its depth. So hence this remains unchanged when it comes to the large squares. If I want to find out what is the concentration or the number of cells of the yeast in the given sample, we have to enumerate it for 1 ml, where for 1 ml of the given suspension, what is the yeast cell count? In order to do that, we are going to take up this formula where we are going to write it as the number of cells counted into total number of small squares into the volume divided by number of squares counted, as in the number of cells counted is what we have to count, where to enumerate the yeast cells we are going to take 5 parts from this haemocytometer, where the first one is the A will be these 4 squares from the first topmost corner, and this is B, the entire thing, and this is C, this is the entire thing, and this is D, and this is the entire thing, and E would be the centermost square of the centermost small square of the centermost large square, as in the centermost large square is this, only this we are going to take into consideration. This is going to be your E. A, this is A plus B plus C plus D plus E. E as in only this. When we take this one small square, it is believed to have, this one square is believed to have 4 into 4 partitions in them. 4 into 4, the division is 4 into 4. So this one large square is further divided into 4 small squares. So now this is going to be the large square and the partitions inside them is going to be the small squares. To come back to its partition, where the entire hemocytometer is divided, where the four corners have 4 into 4 cells and in the center it is 5 into 5 cells, where this large square, one large square has 4 into 4, that is 16 squares within them. So the number of cells counted would be A plus B plus C plus D plus E. E as in only this. Here, in order to make this counting also easy, we have to count what is the total number here and write it. Total number here and write it. Total number here and write it. Total number here and write it, and add all together. That will be your C. The same way we're gonna start counting the entire thing for A, entire thing for B, entire thing for C, entire thing for D, and E is only the cells that are there in the centermost corner. So when we get the total, maybe it is 600, you will write that 600 here into 400. 400 will be the total number of small squares. As I told you, now this is going to be your large square, as in the total number of small square will be your 25 into 16. Here we know there are 5 into 5 squares, that is 25 into 16, because each square here has 16 partitions further. This is further divided into 16. This is further divided into 16. This is further divided into 16. So that way we have 25 into 16, that is 400 squares. Here we have 60 and then we have the volume that is written divided by 80. What is this 80? Is the number of squares that we have counted. This is a number of cells counted, number of each cells that is counted. This is number of squares counted, as in we are going to take what are the squares that we have taken into consideration. These are the cells that are taken into consideration. That is your A, B, C, D and E. That is A is 16, B is 16, C is 16, D is 16. That is 16 into 4 is 64. 64 plus another 16. So here we know that each large square is divided into further 16 squares. So this square is further divided into 16. So this is going to be another 16. So 16 plus 16 plus 16 plus 16, that is 64 plus another 16. So 64 plus 16 is going to be your 8. That is the total number of squares counted. So when we write the total number of cells, for example, if it is 600 or 500 or 80 or 90 into 400 divided by 80, and the volume remains the same, so that we express the answer, the final answer, in the centimeter cube. So here, this is how we are going to enumerate the yeast cell given in the suspension of about 1 ml. What is the total number of cell count in 1 ml of the given sample? So the most commonly asked question here is, why are we taking these 4 corners only? Why aren't we considering all the cells inside the center? Because that is because here, as I told you, it is also used for enumeration of red blood cells or WBCs. So that case we take this because the yeast cells is comparatively larger. We can enumerate in the larger cells itself. The smaller the cell size, the smaller squares are required. Since this is quite bigger in size comparatively, we can assay it using these large squares only. And the one more question usually asked is, why are we taking this cell in the center? That is to keep the count more accurate. This is further partitioned. So in order to keep it more accurate, the average answer would be got accurately. So we are going to keep it there. One more question we get is, there are 2 cells here. There are 2 steel plates here. On which one do we place the cell suspension? It can be on any of it and never in the center or in the side. It should be on the steel coating that is there. So this is how the hemocytometer, that is the Neuber counting. Neuber counting is nothing but the hemocytometer becomes handy. Very simple methodology to assay the yeast count, to enumerate the yeast count in the given suspension. So that is all we have for today's video, and I hope this is helpful to you. Thank you.